is in the absence of any involvement of third body, so there is no force either in this direction or in this direction, external. So we will apply law of conservation of linear momentum. If it is a one-dimensional collision, you will have only one dimension, m1 u1 plus m2 u2 is equal to m1 v1 plus m2 v2. If it's a two-dimensional collision, you apply this in both directions, x-axis, y-axis. Again, x-y directions you can choose as per your convenience. Okay, x-axis and y-axis. The only restriction is that x and y should be at right angles to each other. Rest it is up to you which two directions you choose, which two right angled directions you choose. Any two right angled directions will serve the purpose of x and y axis. So you have to apply this along the two directions separately. Or if resultant wise you are using, then it's well and good. Just one equation will give you. In fact, both the equations you obtain is from single equation only. Isn't it? What is this actually? This is x component plus y component. 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 So when you extract x components, you will get one equation. When you extract y components, you get the other equation. So that is actually a single equation. The second, a very important thing, you have what is known as coefficient of restitution. Coefficient of restitution. Okay. Sometimes rarely known as coefficient of elasticity. Less commonly known as coefficient of elasticity, because it depends on the elastic properties of the two bodies undergoing the collision. Okay, whichever two bodies are undergoing collision, the nature of the body, elastic property, that is Young's modulus, modulus of rigidity, etc., all those things together decide this. So it is a constant which usually lies between 0 and 1. Why I told usually lies, I will tell you later. For most of the bodies it lies between 0 and 1. Okay, it's a constant depending on the nature of material. So you will have to apply Newton's law. Okay, Newton's based on his experiments. He conducted several experiments, and based on his experiments he gave this law. Along the line of impact, the relative velocity of separation is equal to E times